Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. My guest today is Evangelos Danopoulos. He works in public health and environmental health. We're going to talk today about microplastics and about a little bit about his background and everything. So, Evangelos, thank you for coming.
Thank you for having me, Richard.
If you would, tell me a bit about your background and how you got to working with, environmental concerns.
Yeah, well, I haven't had the most traditional path to research. My background, my undergraduate degree is in public health. And then after that, I started working as an environmental health officer for quite some time, almost 10 years, really. And then I decided to go back to university and do a master's in environmental health, which kind of sparked my interest in research. And then a few years after that, I started doing my Ph.D. in medical science, and I focused in microplastics. I've always had an interest in public health and environmental health and pollution and how it can affect us, really. And through my job as an environmental health officer, I've always been interested in food and drinking water and how pollution can affect that, and then in turn us.
What does an environmental health officer do? What was the role like?
So the role is really a big part of the job is inspecting all the premises that handle food. So from industry to the local cafe, every business that offers food. Also, you work with other services and you participate in, sampling water, sampling food, see, what might be in it that's harmful. And also you do a lot of inspections in schools, in hospitals, in gyms, in pools, really, everywhere that can affect human health somehow in that sense.
I see. So you would go into businesses and sample, make sure everything's up to code, nothing is unhealthy or kept at the wrong temperature, that kind of thing.
Yeah. A big part of it was that, yeah.
Was there any, before we move on to microplastics, was there anything interesting from those days that you learned from doing that job?
It's like I've got many.
Do you never eat out anymore because you've been so traumatized, or what do you think?
Yeah. Well, when I first started doing the job, for a few months, it was a bit shocking in to seeing some stuff. But then after some time you get used to everything, and really most businesses are up to code, and most businesses want to be good and want to be, clean and hygiene. So, yeah, but I know what you mean. Yeah.
Okay. And then what got you interested in plastics and microplastics? How did you go that direction?
Yeah, so I wanted to go back into research. So I was looking at my options and what projects were available in the UK because I was living in England at the time, as I am now. And I saw this project being advertised, and they were looking for a PhD student, and it immediately caught my attention because it was, this novel pollutant that, well, back when I started 4 years ago, almost now, we had very little information. So really you could do, the limits were, it was just a novel area, and you could do wonders with it. You could really start into something completely new and see if it can affect human health. And it was very exciting to me because I was already, as I just said, interested in those kinds of things.
Okay, and what's your focus in the world of plastics? What are you working on in particular?
So what I was focusing on is really how microplastics, well, maybe I should just give a brief definition of what microplastics is because not everybody knows what they are. So when plastic is released into the environment, most of the times, inadvertently, after a long time, it degrades into smaller and smaller particles until it becomes microscopic, or micro, as we call it. So the largest parts in this size range, you can actually see them. So it's up to 5 millimeters, and then this can go down to a nano size, when of course you can't see it. So this is the focus of this is the new pollutant, this emerging pollutant that I'm focusing on. And what I particularly focused in was whether these microplastics can be found in our food and in our drinking water, and whether human beings are exposed to them.
All right, so you're focusing on drinking water. Well, what do you test? Do you test bottled water or water from the faucet, or like where do you test it?
So part of my projects was actually testing things and trying to find microplastics in, my colleagues were trying to find microplastics in seafood and in fish, and also other people in my research group and myself were trying to find whether microplastics are in the atmosphere so that we can breathe them in. But the papers that I have published past 2 years, they were mostly a systematic review and meta-analysis of various papers that have been published around the world and bringing those data together and to see what is the level of contamination in seafood, in salt, and in drinking water around the world.
Okay, so when you say contamination, what have you found in various bodies of water? What are some examples?
For example, for the drinking water, the studies focused more on both bottled water and tap water and found different ranges of contamination. The bottled water was more heavily contaminated than drinking water. Just to give you some figures, the maximum reported microplastic contamination in tap water was around 600 particles per liter, while the maximum contamination in bottled water was almost 5,000 microplastics per liter.
Jeez, that's crazy. And this is in bottled water, certain brands. What explains the difference between a low amount of microplastics and a high? Is it water that was stored in the sun, or how does it happen?
That's a very good question, and I'm afraid I don't have a simple answer because very different things are being investigated right now. The obvious, assumption is that bottled water is found to be more contaminated because it is in contact with plastic bottles and also it is being processed, in factories, whereas the tap water is not. So that is one of the sources that is being suggested, but it's not definite.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
So if you compare tap water and bottled water, again, what are the average amount of I don't know if you call it a plastic piece or just numbers of microplastic pieces, so what's the difference between the two you've observed? Can you restate that?
You mean in terms of how heavily contaminated they are, the numbers?
Yeah, tap water on average, and I know it varies, versus bottled water on average.
Yeah, so as mentioned, the maximum reported in tap water was around 600, and the maximum in bottled water was around 5,000. So that's a huge difference, really.
Yeah, those are maximums. Is there any typical? Is there any average?
Yeah, I don't have the figures in front of me right now, so I'm afraid I can't answer that question.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Well, what are some of the possible sources of microplastics in bottled water? Like, at what points in the journey do you think that they get into the water? In the beginning, when the plastic is first being extruded, maybe it hasn't cured all the way, and now water is filling it at an early stage. Maybe later on, again, it sits in the sun or in transport, experiences a lot of thermal variation. I mean, what do you think are the factors that cause so many microplastics to be in bottled water?
Yeah, well, all these are really hypotheses because they don't have a way of determining exactly right now, because that would take a different kind of study to determine what the origin is. But all of the things that you said are valid hypotheses.
Well, it seems like it would be easy to do an experiment where you get, a case of bottled water, you sample it, see what the level of microplastics are, you leave it out in the sun for a couple hours, and then cool it down and see what the level is now. It seems like some simple experimentation would start to shed light on, some of the sources of it. Maybe tell manufacturers best practices, or, don't let this thing sit in the sun, or, don't fill the bottles until 24 hours after they've been extruded, the plastic, so it reduces the leaching. Is there any experimentation you know of?
No, I can't say that I do. But you must understand that this is extremely novel, this contaminant. So all of these, the things that you just suggested right now, these are things that are being investigated as we speak. And there's new research coming out of microplastics that really tens of papers are published almost every week. So this is, where we are now, and all these things are being tested right now because this is so novel.
Well, if I was there with you in the lab, how would we test a sample of water for microplastics? What does the test look like?
So the test would look pretty simple. One of the most difficult things to do in microplastic research is create a microplastic-free environment, because microplastics are everywhere in the atmosphere, and it's very hard to create a clean lab per se. So the first thing you need to do is try to do that, or remove any plastic material from the environment, even the clothes that you wear, even the gloves that we in the lab must not be from plastic, it must be other material. And then you would take the sample. For water, you would do filtering, and then in some cases you can also prepare the water before the filtering. But for drinking water, it would be clean anyway, so just filtering would be enough. And then you would dry out the filters. And then there are different ways that you can analyze the filters. What we have been doing is trying to put the filter as it is using in a FTIR. And FTIR is a Fourier transform infrared spectrometer. So it's like a very high definition microscope, let's say. It's not a microscope, but just to give you an idea, it creates a spectrum. So if you put the filter under it and you point this device on a specific particle, then this particle would create a specific spectrum. And then you can compare that spectrum to a library, and the library will tell you if it is plastic or if it is something else. And then you would know if that is actually plastic or not. And at the same time, you would also note down how big this plastic is, the dimensions, and also a lot of researchers also note down the color of the particles. because that sometimes helps us determine their origin.
How about the size and the morphology of the particles? I would guess different plastics make perhaps different shapes, and they have different reactive and non-reactive sites. Has anyone been able to characterize them?
Yeah. You see different sizes and different shapes, and different shapes are more frequent in different mediums. For example, in the atmosphere, we found a lot of fibers. In food and in drinking water, we find irregular fragments. See how you can visualize how this plastic has been degrading over time and, coming down to an irregular shape. And sometimes we also find sphere-like particles. So really, there's a whole range of different shapes.
And I guess no one has characterized where fibers go and get lodged versus, more spheroid type particles in a human body or in a rat's body or a mouse's body. Has anyone done any of that?
A lot of research is going on at the moment. So there are studies using animals, and we have now around 5 papers on analyzing human tissue or feces when you've been able to identify particles. The problem with the animal studies is that we ourselves choosing what particles the animals are being exposed to. So really, it's up to us to decide what kind of particles we are. if you're choosing spheres or irregular particles. Other further problem in microplastic research that unfortunately at this point we don't have reference materials. So the material that you can buy to use in experiments are really pellets, and all pellets are spheres. Most of them are spheres. So there's a disconnection from what you would actually find in nature and what we are using in our experiments.
Well, probably the fibers would be the most dangerous because I'm sure they aerosolize as you find them in the air, and people and all kinds of creatures are breathing them in, and they're lodging in people's lungs, and who knows if they're getting coughed out or what they do in there. So I wouldn't think, unless they were like nanoplastics, that spheroid or irregular shaped ones would be able to be aerosolized. So again, I would guess there's probably a major division between fibers and non-fibers.
There is the hypothesis that maybe there would be a similarity with other fibrous material that we find in the atmosphere and that, do get lodged in in our lungs. Asbestos being the one that, almost everybody knows. We don't know if they're going to behave the same way. There has been research that has, hypothesized that it might be very similar.
Okay. Well, what are some of the major hypotheses you're working on right now? What's your lab work look like?
So I'm not doing lab work right now. I just finished a paper that was actually published a couple of weeks ago, and we were taking samples from the atmosphere really to sample atmospheric fallout, and to try and see how much microplastics is in the atmosphere really. So we just picked different areas in Hull, that's a city in England. We sampled the atmospheric fallout to see how much microplastics is in the air. So that was the last thing that I did in a lab.
So what is some of the important experimentation going on now, and what's it trying to figure out that you've observed?
Yeah, so, there's a lot of research going on surrounding microplastics. And of course, it's not only focused on the human health side, which is what I'm interested in. There's microplastics research going on for all compartments of the environment, major concerns about fish and seafood and how it can affect them. And also, going up the food chain in really every animal. There's also research for plants, if they can be uptaken in plants, which has also been proved. Lots of research on atmospheric contamination. There's a lot of interesting stuff in this area. What I'm interested in is trying to prove or try to figure out whether these microplastics that are found in our food and our drinking water, whether they can pose a risk to our health. So what I want to do in the future, if I get the chance, is to bring together research from studies on animals and see if there's a significant adverse effects caused on animal health, and then try to extrapolate that to human health.
What about under a microscope? Have you looked at various, irregular microplastics or fibers? And if so, what do you see? What are people seeing looking at it?
It just seems like, I don't know really how to describe it. It just seems like an irregularly shaped particle, really, like a little puzzle piece.
What about microbes? Has anyone found that certain plastics and certain shapes tend to attract certain microbes that will live in and amongst the plastic and stick to it?
Yes, there's been research on microplastics and larger pieces of plastic that in the ocean for a long, long time, and it has been found that they can be colonized by microbes, and in some cases also that helps the microbes get to places that they wouldn't be able to go before because they're using the plastics as effectively as rafts.
Oh, interesting. So, did they find that certain microbes were always on plastics, or is it changed, with each kind is unique, or how do they characterize the variation of microbes that they found?
I don't have the details now, just on the top of my head, but they have found different microbes on microplastics.
Well, very interesting. Evangelos, what's the best way for people to find out more about your work? Where can they go to keep tabs?
Well, I am on social media, and I am on Twitter. If somebody just looks up my name, and also my papers are being mentioned in York University and Hull University, and they can find updates on our work there. Also, my main affiliation is the Hull York Medical School, and you can find more information on that webpage as well.
Okay. Well, very good. Evangelos, thank you for coming on the podcast. I appreciate it.
Well, thank you for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes. You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.